Hello everyone, welcome to Cheenta School of Statistics and Data Science. So we'll be looking at the solution of two very interesting problems from the CMI 2019 exam, the MCQ part specifically of question number 17 and 18. So both these questions focus on probability and statistics. So we'll be exploring two very salient concepts in these questions that you should be looking out for when trying to solve in explosions in these patterns. Right? So let's look at the question. It comes in two parts. So the first part basically outlines what is a cumulative distribution function for the standard normal distribution. So what we have here is basically this big part, which is nothing but the CDF of a standard normal distribution. But we generally don't need to look at this because here we are given the values for the CDF at some specific values of A, right? And we also know that x is equal to mu plus sigma z follows Gaussian distribution with mean mu and standard deviation z sigma if z is a standard normal variate. So the premise of this question is that there is an exam and the marks of that exam follows a normal distribution with mean mu and standard deviation sigma. So we are told that a candidate fails if he or she obtains less than 35% marks, and they pass with distinction if they get more than 80% marks. So we are provided a table here where we are told that 2% of the students passed with distinction and 82% of the students passed without distinction. So one of the common mistakes which people make here is that they don't see that these are percentages. So many people think that this is basically the number of students, which is not the case. So don't make a mistake. So look at here and you'll understand that there are like 2% students. So basically there are 84% students who have passed and 16% students who have failed. Not 2 students who have passed with distinction, 82 students who passed without distinction, and 141 students who failed. That is not right. So we know what has happened. So moving on to the first question, it is question number 17. We're asked to find out which of the following statements are true. So we have some claims about the values of both the mean mu and the standard deviation sigma. So we want to find out what these two values can be, and we can calculate that using some basic probability. So let capital X be the random variable denoting the marks of a randomly selected student. By assumption, X follows a normal mu sigma square distribution. Now we know that the percentage of students who failed 16%, right? So the probability that the marks obtained is less than is equal to 35 is 0.16. Now why 35? So if we assume that the full marks is 100, then 35% of 100 is nothing but 35. So in reality, this kind of intended in the question to be taken as 35 itself, though not mentioned clearly, but we can kind of go ahead with it. So we can kind of say that, okay, the question was incomplete in some sense, but okay. So X, we know, follows a normal mu sigma squared standard distribution. So let's do some algebraic manipulation here. Let's subtract the mean first and then divide by the standard deviation. So if X is a normal mu sigma square variate, then X minus mu by sigma is a standard normal variate. So this is basically some Z, which is less than is equal to some A, where Z is standard normal. So this is nothing but the CDF of Z, and this is the value at which we want to find the cumulative. This is basically the value of that function. So this is basically 35 minus mu by sigma, which is 0.16. From this little list of values, which will be referring continuously, we have that minus phi of minus 1 is 0.16. So let's come over here and make this basically phi of minus 1. So basically these two are equal, right? So let's equate them. So 35 minus mu by sigma is minus 1. From there, we get mu is equal to 35 plus sigma. So this is the first equation that we have. The first equation is basically a linear equation in two variables, mu and sigma. If we want to calculate the two values of mu and sigma, it is kind of intuitively clear that we need to have another equation that gives us that has either both mu and sigma, or any one of mu or sigma, which will help us to calculate both values from something like a simultaneous linear equation, two equations in two variables. So where do we get this second equation from? Remember, we have another statement where we have that you need to get more than 80% of the marks to become to pass with distinction. Remember, 2% of the students passed with distinction. So let's use that. So probability of x greater than 80 is 0.02. Take its complement. Probability of x less than is equal to 80 is 0.98. Do the same algebraic manipulation again, and you'll get that phi of 80 minus mu by sigma is 0.98. From that little list of values again, we have phi of 2. This is basically phi of 2. Equate these two values, and you have 80 is equal to mu plus 2 sigma. This is our second equation. So basically, we have two equations, two linear equations in two variables, and we can solve them in any manner we want. What I did was basically substituting mu from the first equation into the second equation and solving both. We have mu is equal to 50 and sigma is equal to 15. So these are our answers. And going back to the options, you'll be able to see that the correct option is hence option D. So the one key thing that we used to solve this problem was to note that we have some information that we can convert in mathematical terms to get an equation. Since we are basically asked to find the values of two variables, it really helps if we can formulate two linear equations in these two variables, which we can solve very easily. So that's what we did. Another question of the same continuation of this entire paragraph. So here again, we have four statements which were asked to find if they are true or not. Now you can see that these four statements are in many ways different from the four statements that we saw previously. Here we are told that the average score of the group can take some value, and on the basis of what value it takes, we have to find the probability that it takes that value, or it's less than that value, or it gets greater than that value. So we're using a fact here that if x is a normal, if x follows a normal distribution with the parameters mu and sigma square, then x bar, which is basically the mean of x, follows another normal distribution with the parameters mu sigma square by n. So what is this n? N is the number of observations that we have. In our case, it's 225 because we have the information about 225 students. So let's take each of the statements one by one. The first statement says that the probability that the average score of the group is 220 students is less than 48 is 2%. Bit long and bit confusing, so let's shorten it down to this one. Probability of x bar less than 48 is 0.02. So let's take this statement and then do some algebraic manipulation to get this. Subtract the mean, divide by the standard deviation, because we know that this will be a standard normal variant. Now we know mu, we have calculated this to be 15. We know sigma, calculated this to be 15. We know n to be 225, so square root of n is basically 15 again. So sigma by square root of n cancels out to be 1. So this value comes down to be -2. So this thing is nothing but phi of -2, which we know to be 0.02, which is basically what we have claimed. Thus, statement A is correct. Moving on to B, it is that average score less than 42.5, the probability is 6.7%. Okay. So let's rewrite again this in probabilistic terms. So let's just clean this up and let's write it properly. This should be something 0.067. The probability that x bar is less than 42.5 is 0.067. Now, before we move on to this question, first let's understand that this thing is nothing but the CDF of x bar. The CDF should be non-decreasing. One of the properties of a function being a CDF is that it is non-decreasing. Some others being that it is always positive, it is right continuous, and this one is non-decreasing basically. So if the CDF is basically this, f of x bar at x, then it's nothing but probability of x bar less than is equal to x. So it's continuous random variables, less than is equal to and less than really doesn't make any difference, because at the end of the day we are computing an integral. So this is nothing but f of x bar at 42.5. Now this is, since this is non-decreasing, right? So this is non-decreasing. So f of x bar at 42.5 must be at most f of x bar at 48, because it is non-decreasing, right? So if x is less than is equal to y, because it is non-decreasing, if x is less than is equal to y, then I must have fx is equal to f(y) is non-decreasing. So this is 42.5 and this is 48. So this value should be at most this value, and I know this should be 0.02. So there is no way this can be 0.067, right? There's no way that this can be. This is wrong. So P is false. So this basically contradicts the fact that CDF is not decreasing. That's how I know this is false. Moving on to the third statement, we have that the probability average score is greater than 49 is more than 50%. Let's again write this in probability terms. That is, probability of x bar greater than 49 is 0.5. Again, take its complement. Probability of x bar less than is equal to 49 is less than is equal to 0.5. So let's calculate this value first. Let's calculate this value, and then we will see if it is less than 0.5 or not. So this is nothing but, after doing the algebraic manipulation, it comes out to be -1 here. And I know that phi of -1 is 0.16 from that table, and 0.16 is less than 0.5. So this statement holds true. So C is correct. Going to the last statement, which is the probability that the average score is greater than 57.5 is more than 16%. So it's this probability that x bar is greater than 57.5 is greater than 0.16. Again, take its complement. So probability of x bar less than is equal to 57.5 is less than is equal to 0.84, because basically you're subtracting something, right? You're subtracting 1 minus, you're doing it. So basically the sign changes. So I'm saying that this probability is bounded above by 0.84. Again, so let's basically calculate what this probability is. So it is x bar minus mu by sigma by root n. Like basically we are standardizing it. And this side it comes out to be 7.5. So phi of 7.5 is far greater than phi of 2, because again it is not decreasing. Phi of 2 is 0.98. So phi of 7.5 is much greater than 0.98, probably something less than 1. 0.98 is greater than again 0.84. So this probability is greater than 0.84. So this statement doesn't hold. So that means this statement doesn't hold. So D is false. So what we have seen here is that this holds, this holds, this doesn't, and this doesn't. So another key takeaway from this statement is that not all identical statements, identical looking statements, you have to like you need not approach all these statements in the same manner. One, you can calculate the probability. One, you can use a non-decreasingness to disprove it. You can use some inequalities to get what you want. So there are different ways of attacking the same problem, different ways of attacking same statement, almost similar looking statements. So these were two very interesting problems that I wanted to bring to you. So thank you for watching. I'll see you in the video. Goodbye.